Hello friends, I'm Siddhant Wagmare signing in as RPI boy, and today I'm going to show you how to make a Bluetooth controlled buggy using the Raspberry Pi and a motor controller board called the L298N. So let's begin. First, let's talk about what we are all going to need. So first thing is the RPI boy. Obviously, we are going to need it, and to power the RPI up, we are also going to need a power bank of 5 volts or 5.1 volts, according to the model you are using. So I'm using a 3B, so I'm going to use 5 volts, but if you are using 3.3B plus, you can use 5.1 volts as well. Then we are also going to need the L298N, a Chasis, along with a ball castor, and we are also going to need a battery, which is connected in series. It's 9 volts. You can use parallel as well if you have 12 volts or more. Then we are also going to need 2 motors and wheels, which is obvious. Well, then we are also going to need some male to female or male to male jumpers, and some female to female jumpers as well. And we are also going to need a device so that we can control our Raspberry Pi using the Bluetooth. So let's begin. Now, first we are going to wire the motor controller board to the Raspberry Pi. So for that we are going to need the GPIO pin chart, which is like this. So we are going to use these female to female jumpers to connect them. So if you observe, there are some headers over here on the lower part of on the front part of the board, and if you read the given information, it says input 1, which is on the left side of the board, which is here. This is input 1 on the left side. This is input 2, this is 3 and 4. So we are going to line them up with 1 will be going to 7, 2 will be attached to 8, 3 will be attached to 9, and 10 the GPIO 10 will be attached to input 4 on the board. So let's do this. So I'm going to use white for input 1. It's good if you to know which color you are using, to use different colors for each of your pins, and then black for 2, gray for 3, and green for 4. Yeah, here it is. So let's find I'll find out where the positions of the wire of the jumpers on the Raspberry Pi GPIO setup. So the 7th GPIO 7 is the 26th. I think all the viewers know that the GPIO pin numbers are lined up 1, 2, 3, 4, 5, 6 and so on. So it's 26th pin, which is I believe 1 2 3 4 5 6 7 8 from the USB, the side of the USB, and on the lower line 1 2 3 4 5 6 7 8. So it will be here, somewhere here on the lower side. So I'll confirm it up again. Yeah, 1 2 3 4 5 6 7 8. 1 2 3 4 5 6 7 8. Yeah, the 8th is just next to it on the right, and ninth one, the ninth is ninth GPIO is diagonally opposite to 8th over here, and the 10th is lined just next, just right to, just on the right side of 9 over here. So it will form a sort of Z on the GPIO header. So now the Raspberry Pi is lined. Now we are going to need power for the motor controller board. We are going to need the power for motor controller board as from the Raspberry Pi, as well as the battery pack. So what I'm going to do is 5 volt will be coming from the Raspberry Pi. So I'm going to take a male to female jumper lead. Yeah. And I'm going to use the male header in the plus 5 volt. I'll just take the right driver. Yeah, this will do. Yeah, so I'm just going to tighten the header up on the 5 volt terminal. If you don't know which is the 5 volt terminal, it is on the left, right, if seen from the front. The labels are also given over here. This is 5 volt ground. They have not given separate grounds, but the ground is common, and this is the 12 volt. So I'm going to connect the 5 volt header over here. I'm going to use this. Take this. Yeah, so I just tightened the 5 volt header on the motor controller board, and the female jumper will go on the first pin on the lower row. Yeah, first pin on the lower row from the side of the Wi-Fi module. Then we are going to take another wire lead, another male to female, and an open stripped end and a male jumper for the battery pack. So this is what we are going to stick in this center terminal. Yeah, so I just tightened the screw of the ground terminal. Now we are going to fix the positive terminal, 12 volt terminal, with another stripped off end and male jumper, which we are going to connect to the positive of the batteries. Yeah, so I just uh fixed the new VCC cable for 12 volts. So now I'm going to just try it if the battery pack is working. This will go on the third GPIO, just second from the 5 volt, and this will go in the ground. Yeah, so if you can see, I have not powered the RPI on with the power bank, but because it's a GPIO, so it is taking the power from the motorboard as well. So we can actually power it on with this method as well, but I'm not going to use this method. So I'm just going to remove these up. So now I'm going to wire the motors up. So I'm going to be using them like this. You'll have to mark which motor you are going to use for your left side and which are you going to use for your right side. So it will be going on like this, and I have already put some marks on the terminals for output terminals. You may not be able to see, but there are some marks. I used permanent marker. Yeah, this is for black, L, the other side is blue, means U, and the one here is yellow, Pi, and the other side has green. So I'm just going to so I just wired up the one motor on the right. Now I'm going to align the left motor. So actually I have already taken the wires through the hole on the chassis, so it's why it took time. Now I'm going to wire the second motor up. So now, as you can see, the motors are connected to the motor controller board. So now we have to check if the motors are running according to the means are the motors running correctly. So for that we need to plug in the Raspberry Pi and check. So now I just booted up the Pi, and now I will start the Python 3 ideally. So as you can see, the screen appears, main screen appeared. This is the Python 3 ideally main screen. So now I'm going to just open the file. It was in recent modules, yeah, robot.test.py. So in this program says that when we have just imported GPI robot from GPIO and time from sleep from time, sorry, and we have given robot the variable. This is the variable, and we have defined it as GPIO 7 and 8 is left and right is 9 and 10. So robot forward is means both the motors should move anti-clockwise, and then it will stop. Right, backward, stop. So let's see. Run module F5. So as you can see, the motors are not moving. Actually I haven't plugged in the power supply. So the motors will not move. So I'm just going to plug in the power supply here so that it doesn't stop. So if you can see, the motors are moving, and for now they were just moving backwards. So I will just run it again so that I can check. Yeah, it is moving forward, then right, and then back. Yeah, this is back. Yeah, so the motors are moving correctly, and now I can just check. I just fix the motors and wheel, and I'm just going to shut it down for now. So yeah, we are almost done. Now we just need to fix the wheels and program it again. I just finished the screwing the wheel and the motor on the chassis. So now we are going on for the programming. So by now I think the app has been installed. So yeah, the app is installed. Just a minute, I'll just clear this up. There are some things up to make some space, and oh sorry, yeah, so the icon is like this. It's just a blue dot. So running on Bluetooth, yeah. Then it will ask for some permissions, like if it can turn the Bluetooth on. So you just have to give it the permission, or you can manually switch on and off. So now I'm going to plug in the RPI and boot it up. So yeah, I'll just open the module up. Recent files, video, yeah. So this is the programming. I'll just zoom it up, zoom in, zoom it on. Yeah, so the first line here says that import from bluedot, import bluedot, which is the name of the software we just installed. We are going to use this software to control our bot. Then from GPIO 0 we imported robot. It is for controlling the GPIO, and the BD we have given blue dot a variable, and robot is which is the pins GPIO pin 7, 8 and 9, 10. We gave it a variable robot. So, and then we also defined move means and the position of our finger on the blue dot is, if position up is on the top, the robot will move forward, else if the position is on the bottom, robot will move backward, else if position right, robot will move right, and else if position left, robot will move left. Then we also define stop, robot dot stop. So Then we have programmed it like blue dot when pressed equals to move. Means if we press the blue dot on any of these positions, it will move. When moved, it will change the direction. If we just change the position of the thumb or whichever finger we are using from top to bottom, it will start moving backwards, and and when we release our finger, it will stop. So let's check the programming up. I'll just connect the battery pack before we start. Yeah. So I just connected the battery pack. This is the our robot. I'll zoom out a bit. Yeah, and this is the device we'll be using. So first we need to connect. First we need to pair the device using Bluetooth. Raspberry Pi. So yeah, I just connected Raspberry Pi. So now when I run program, I would be able to see a sentence on the ideally block server started, and the name of the device with which it has been connected, and waiting for connection. Means when we connect, press the button connect on the device, we'll just have to restart the app again. Yeah, so if we click on Raspberry Pi, the client connected, it will show client connected. And then when we move our finger, you see, so I'll just tape some things up and resume. So now, as you can see, just disconnected all the wires from the RPI except the power cable. I removed the mouse and the HDMI cable. So now let's see. Subscribe and like if you like the video, and please comment below if you want to see more videos like this.